Hi students, Friday, day 8. We're still going to work with dilations. This time we're going to determine what the scale factor is. Now yesterday you started finding the scale factor if the shapes had horizontal or vertical lines. So we're still going to continue that, finding the scale factor if it has horizontal or vertical lines. And then I'm going to show you how to find the scale factor if it doesn't have a horizontal or vertical line. And then we're also going to determine if the dilation is a reduction or enlargement, if it gets smaller or if it gets larger. You do have a note sheet that you should have picked up at the door. And you will not need your spiral notebook today. Some vocabulary words we went over a little bit yesterday. Dilation is a transformation that changes the size of the shape, but not, or the size, but not the shape of the figure. Similar figures with the same shape, but not necessarily the same size. These are all on the front side of your note sheet. You can just add to it if you need to. The ratios of the measures of corresponding sides are equal, and the measures of the corresponding angles are equal in similar figures. And remember, when we write the scale factor, the ratio of the corresponding lengths, we are going to put the image side length over the pre-image side length. And remember, the image side length is the prime letters. So you're going to label it, and these are going to be the prime letters, and then the corresponding numbers for that side length. If the scale factor is greater than 1, then the dilation is an enlargement. So if k is greater than 1, the dilation went bigger. If the scale factor is between 0 and 1, the dilation is a reduction. If the scale factor is equal to 1, then the shapes are congruent, meaning that they are the same size. We will not look at scale factor less than 0. And then to write an algebraic representation, you would replace k with your scale factor. So everything is the same except you're going to replace k. So say, for example, you calculate k equals 2. Then your algebraic representation would be xy becomes 2x, comma, 2y. That means 2 times the value of x and 2 times the value of y. Okay, this is just me, so pencils down and you can just watch. Again, we're going to find the scale factor. So when you need to find the scale factor, you want to find k, you need to look at 2 sides. I only need the measurements of 2 sides. So here's a vertical side and a horizontal side. So we're going to take those 2 sides. And you still got to write up your ratio with the letters. B prime, C prime over BC. And then you can count. So B prime, C prime is 3 units. BC, 1, 2, 3, 4, 5, 6. So my scale factor is 1/2. And then I need one more side. C prime, D prime over CD. And this is 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. 4 over 8 simplifies to 1/2. My k is 1/2. So I found the scale factor It's between 0 and 1, so this is a reduction. And then we're going to write the algebraic representation. xy becomes 1/2 x, 1/2 y. So here's my answer. All right, so let's try one together. This is on the back side of your note sheet. And we're going to find the scale factor, and then we're going to write the algebraic representation and also determine enlargement or reduction. All right, so here is a vertical side, so we're going to take this side, A prime C prime over AC. And it doesn't matter if you write it A prime C prime, or if I said C prime A prime over CA. It doesn't matter which way you do it. They both mean that side length, this side length. So if I count the prime, 1, 2, 3, 4, this is equal to 4, and then AC is 2. 4 over 2 is equal to 2. Now I got to test this side. I have C prime B prime over CB. And then count 1, 2, 3, 4, 5, 6 over 1, 2, 3. 6 over 3 is 2. My K equals 2. So right on there, K equals 2. And is it an enlargement or reduction? Well, K is greater than 1, so it's an enlargement. And then we're going to write our algebraic representation. So that's going to be xy becomes 2x, 2y. All right, so let's do this one. This is the next graph on your note sheet. And remember, you only need 2 sides. There's 4 sides, but the other two of them are equal, right? These 2 sides are equal. The 2 horizontal sides are equal, so you only need 2 sides. Go ahead and write up your first side. Let's take this side right here, R prime to S prime. Write up the ratio and count your units. You should have R prime S prime over RS, and it's 1, 2, 3, 4, 5, 6 over 2, 6 over 2, 3. And then write this other side up. Okay, you should have S prime P prime over SP, and this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 over 3, which is 3. So my K equals 3. It's greater than 1, so it's an enlargement. And my algebraic representation, go ahead and write up an algebraic representation. Okay, you should have written up xy becomes 3x, 3y. All right, so that's when the sides are vertical and horizontal. Go ahead and do that one. Substitute, please hit pause and give the students a chance to work on this. All right, you should have finished. Scale factor is 0.5 or a half, and you could have picked either of these sides, D prime, D prime, E prime over DE, or you could have picked E prime, F prime. They're both going to be the same. We have 2 over 4, which is 1/2. And then either the top or the bottom, doesn't matter. D prime, E prime over DE. And this is 3 over 6, which is 1/2. So it is a reduction because it's between 0 and 1. And we have xy becomes 1/2 x, comma 1/2 y. And you can use the fraction or you can use the decimal, it doesn't matter. All right, so now what happens if there's no horizontal or vertical sides? So what you're going to do is you're going to pick a vertex point. And I would tell you not to pick a vertex point that is on an axis line, because if you pick one that's on an axis line, then you have to pick 2. But if you don't pick one on the axis line, chances are you only need to pick 1. And the other thing I would say is don't pick one where the ordered pair is the same number. Like this one right here, this is -1, 1. So you have a 1 in both of them. Don't pick something like that. So let's pick H. And I like to choose ones that are more in the positive numbers, like in quadrant 1 if I can. So we're going to pick H. So we're going to say H prime over H. And what we need is the ordered pairs. So the ordered pair for H prime is right here. Oh, and let me tell you, if it's not on the intersection of the grid lines, you're either going to have 1/4, 1/2, or 3/4. So if it looks like it's halfway between 0 and 1, it's going to be 1/2. If you look over here at L prime, do you see how it's really close to the axis line? That's going to be 1/4. Okay, so H prime is, I'm going over, does it look like I'm going over 1/2 or 1/4? So going over, so you're going to write the XY ordered pairs. Going over, I went over 1/4. Okay, this is 1/4 right here. So I'm going to write it as a decimal. 1/4 is 0.25. So 0.25, 0.5, or 0.75. And then how much did I go up? I went up 1/2. So that's 0.5. So this is my ordered pair. 0.25, 0.5. I'm splitting it up into 2 fractions, the x fraction and the y fraction. Now I'm going to write the H ordered pair. The ordered pair for H is 1, 2. So I'm going to put 1, 2. Now, I just need to simplify, and that is my K. 0.25, 25/100 over 1 is 25/100. If I take this one, if you don't know how to simplify that, just divide, bring your decimal up. 2 goes into 5 twice. 1 left over, add a 0, bring it down, and it goes, 2 goes into 10 5 times. So this one is 0.25. So as long as they're equal, that is my scale factor, my K. Now, your scale factor is between 0 and 1, so this is a reduction. And I can write my algebraic representation. XY becomes 0.25x and 0.25y. Okay, so that's how you do it when you do not have a horizontal or vertical side. Okay, go ahead and do this one. Teacher, if you can press pause and come back in a couple minutes when you see everyone has completed. Okay, you should have completed by now. And let's see, which shape or which vertex point will I pick? I think I'll pick D. I'll pick D and D prime. D prime over D. So for D prime, the ordered pair is -1, -0.25. And D is -4, -1. All right, so the prime, I'm going to write it as a fraction. So remember, you're writing an x fraction and a y fraction. -1 and -0.25, that's my prime ordered pair. And then -4, -1, -4, -1. So my K, a negative over a negative is a positive. 1/4 is 1/4, or 0.25. And then negative over negative is positive. 0.25 over 1 is 0.25. So this is my scale factor, 1/4 or 25/100. It's between 0 and 1, so it's a reduction. And then my algebraic representation, xy becomes 0.25x, 0.25y. And it doesn't matter if you have 1/4 here or 0.25. Same thing. Okay, next example. I'm going to skip this one and we're going to work one together. Okay, so this one's on your note sheet. Now, they gave you the ordered pairs for the vertices. And so you just pick one point, one vertex point, and you write up the fractions. Now, if you pick one that has a 0, then you got to pick 2 vertex points because there's only one fraction that you can make out of that. If you pick one like T that has the same numbers for both, then you got to pick another one. So my recommendation is that you pick a vertex point that has no zeros and different numbers. Don't pick one where the absolute value of both of them are the same, like 1 and -1. Don't pick this one. So let's do H. So we're going to write up H prime over H. And then again, we need the x, y ordered pairs. We're going to make 2 fractions. The x, -2, oh sorry, we want the prime. H prime, -5, the y, -2.5, and then H, -2, and -1. So now I can simplify this. Negative over negative is a positive. 2.5 over 1 is just 2.5. 5 over 2. If you don't know what that is, you can always divide. Goes in twice. 4, add a decimal 0, bring it down, goes in 5. So a negative over negative is a positive. This is going to be 2.5. My K is 2.5. Is this an enlargement or reduction? Tell your shoulder partner. You should have said enlargement because it's greater than 1. And then go ahead and write your algebraic representation. All right, xy becomes 2 5/10 x, 2 5/10 y. And there's my answer, that and enlargement. So remember, if you're going to pick the vertex point F, then you got to pick another point because you need two different fractions to make sure your scale factor is the same. If you're going to pick something like T, where the absolute values of the numbers are the same, then you're going to have to pick another vertex point so that you can have two separate fractions. All right, here's your turn. Teacher, if you can press pause and give the students a couple of minutes to work this out. All right, so you should have had time to work it out. And so if I look at these, they're all about the same. Maybe I'll pick n because they're all positive numbers. N prime over n, 4.5 and 3. These are my ordered pairs. This is going to be the x, this is the y. And then 3 over 2. Again, if you don't know what this simplifies to, you can always divide. 4.5 divided by 3. 3 goes into 4 one time. Bring down your 5. Bring up your decimal. That goes in 5 times. 1.5. How many times does 2 go into 3? 1. And then it's 1/2 left over. So 1.5. Enlargement or reduction. This is an enlargement because your scale factor is greater than 1. So you would say k equals 1.5. Your algebraic representation, xy becomes 1.5x, 1.5y. And that's it. That's your lesson. Homework. Enjoy the rest of your day. Start your homework for the last few minutes of class, and have a nice weekend. I'll see you all on Monday. Please be good for the sub. Thank you very much. Bye.